When it comes to data visualization in R, you have an extensive collection of functions and add-on packages available. I think that for nearly any standard or even slightly exotic problem, R has you covered. For standard plots like histograms or scatter plots, there are probably more than 10 functions for you to choose from. On top of that, you have of course all sorts of arguments you can use to tweak the plots. But before we take a closer look at plots, I want to elaborate on two very important points. First point is that data visualization is great for beginners. And second, I want to tell you a few things about the 3 gears of plotting in R, which you maybe will hear about sooner or later. So why is data visualization important for beginners? This topic has the advantage that it is, well, very visual. That means you instantly see what you did with a certain tweak in your code. That way you easily get a feeling about coding. It's quite an intuitive way to get students into R or programming as a whole. And you see results right away, which makes it more exciting. In fact, starting R with plotting is a viable solution for very visually oriented people. So now let's elaborate a bit on the 3 gears of plotting in R. Basically, you have 3 different systems in R to produce your graphs. There is RBase, Lattice and ggplot2. In reality, there are several more, but those 3 are the most extensive and popular ones. ggplot2 is the best project of Hadley Wickham, at least in my opinion. You can see it as a sub-language within R. The code you will use for ggplot2 plots is totally different to RBase. With the 2 commands, ggplot and qplot, you can create all available plots. Today, ggplot2 gets more and more the standard of visualization in R. But I do not really recommend it to newcomers. It's an advanced tool. As such, it is wise to build your ggplot2 skills on top of solid RBase graphing skills. RBase graphs are the default way of data visualization in R. This system is part of RBase, so you do not need extra packages for this one. The underlying code is classic R syntax, which you can utilize in other functions as well. I find that for standard tasks, this is very fast and efficient. There are several functions for different plot types. The most common one is plot, which is quite versatile when you manipulate the argument type. Then we also have hist for histograms, boxplot for boxplots, and barplot for barplots as the ones extensively used. Now, those plots are great to get a quick idea about your data, but they are not primarily made for infographics on your website or scientific publications. Speaking about scientific publications, Lattice is the third of those systems. The code used is similar to RBase but has its own characteristics. The most prominent of Lattice features are those plot matrices that are putting several plots on one page for easy comparison. Things like that are easily made in Lattice, and that is the reason why you will see this quite often in scientific papers. Primarily, I would recommend Lattice for people in academia. Now, since this is an introductory course, I will focus on RBase. We will mainly work with the function plot, since it's very versatile. So let's say we have a vector x with the integers from 5 to 7, and a vector y which goes from 8 to 10. Both have the same length, which is crucial to be able to get the scatter plot here. Each x value needs a corresponding y value for the plot to make any sense. So now that we have the data, we can simply use the plot function by stating plot xy, and we get this output down here in the plot window. A classic XY plot with the default settings for this sort of plot. Of course, we can customize each bit of this plot, but more on that later on. First, I want to show you how to plot a data frame. In this case, we are simply using the pre-installed dataset Lynx, which is a time series data. R knows that this is a time series and will therefore adjust the plot type to a line chart. The underlying time dimension will be displayed on the x-axis over here, and the Lynx trappings values are on the y-axis over here. Now it is time to take a look at customizing a plot. Most of this can be done directly in the function by adding the plot arguments. More advanced features of the plot need to be changed on a session level by calling par or parameters. So here in this case, let's say we want to add a title. The argument for that is main, and then in brackets you can add your title name. Here I'm simply calling it Lynx trappings. I also want to change the color of the plot lines. Therefore, I'm using the COL argument, and I will set it to red. I can of course also change the color of the main title. The argument for that would be col.main. In this case, let us indicate the color with a color code. Each color has a specific number in R, and here I'm choosing number 52. To make the main title a bit bigger, use cex.main. Cex is a whole family of arguments. It is the magnification factor for most of the plot components. So here let us put an extra 0.5 to the magnification. That means a cex.main of 1.5. Alright, so if we now run the plot, we can see that there is a whole lot of change going on. We have a title and the coloration of the plot is now changed as well. And of course we also manipulated the font size of the main title. Next, we're gonna work on the axis labels, or more specifically on the axis titles. Let's say we want to delete the title on the x-axis. Therefore, we use xlab. The y-axis here we're going to call Lynx trappings. And if we check out the plot, we can now see that indeed the labels of both axes have changed. The x-axis title is now gone, and the y-axis title indicates that this is where the Lynx trappings scale is placed. We can not only tailor the axis titles, we can also work on the scales. The scales are the numbers on the axis that give our plot values some meaning. Without those scales, the reader cannot make any sense of the plot. The argument we need here is called LAS. So if we set LAS to 2, we completely change the orientation of our scales. Both X and Y scales are now oriented differently. Depending on the length of scales values or the plot layout, this is a valuable feature. Basically, we have LAS values of 0 to 3 available. I will now produce a plot matrix so that you can compare the orientation of those 4 configurations. In order to be able to get a plot matrix with 4 plots on one sheet, we need to set the MFRow configuration to 2 and 2. That means 2 plots horizontally and 2 plots vertically. In other words, a 2 times 2 matrix. This parameter MFRow is one of the base plot parameters that need to be set from par. Par can be seen as the plot configuration of your whole R session. In other words, if you change the par configuration, this will stay the whole R session as long as you do not change it back. At the same time, I will also change the coloration of the axis to red so that you can easily see what we are doing here. Again, with this par line, we are now changing the session configurations to always get a 2 times 2 plot matrix with red axis. With the next 4 lines, we try out all the 4 LAS configurations that are available to us. Those are 0, 1, 2, and 3. I will also highlight the LAS value in the main title of the plot so that you can see it even easier which LAS value produces which plot. As data, I'm simply getting integers 1 to 8. Alright, so let's run this whole block and let's see what this might bring. So that looks quite interesting. We have 4 plots on one sheet, which is now our new session configuration. And we also changed the axis scales to red to simply highlight the scale orientation, because that is what LAS is all about. This is basically any possible combination of horizontal and vertical XY scale combinations. Again, depending on the data and the scale values, this might be helpful in order to produce a meaningful plot.